I'm going to turn it over to Ben Smith, and he's going to go take you through his Spore presentation for the Lunar Homestead.
All right. Hi, everyone. I'm Ben Smith, and I own Lunar Homestead. And Lunar Homestead's mission is to develop the technology and techniques needed for permanent lunar settlement. And today I'm going to talk about my Spore concept, which I'll define in a minute. But first, let's go over some of the challenges that Spore was created to solve. As we all know, the lunar surface is a challenging environment to operate in. And current plans involve mining and building on and in the Regolith. And this has proven to be difficult and expensive to engineer for. Most of you know how dangerous and difficult the lunar regolith dust is. It's very small, averaging about 70 microns, which is finer than the human eye can see. And it's sharp and abrasive like powdered glass. And it gets everywhere and sticks to most surfaces. And it's highly chemically reactive, making it toxic to humans. Breathing it on a daily basis is probably going to cause some chronic respiratory problems, especially as the microscopic particles accumulate in the lungs. And the regolith dust is also hard on equipment. It quickly damages moving parts and fabrics, like spacesuits, and it could cause equipment to overheat. And the real kicker is we still don't know a lot about the regolith dust in its natural environment, and we really don't know much about its long-term effects. We have some ideas on how we could mitigate the dust threat on the surface, but none have really been field tested. We just don't know how we're going to deal with this problem. And then there's radiation. There's three major types of radiation we need to plan for. The solar wind, which we can ignore because we're going to design for the other two. Solar particle events from flares and coronal mass ejections, and galactic cosmic radiation. One source I've read states that 20 grams per centimeter squared of water equivalent material would be sufficient shielding for solar events. However, sufficient isn't quantified. I assume it's sufficient for a short duration mission and based on career limits. However, GCR can penetrate through meters of regolith. Luna does have a very tenuous atmosphere. It's about 14 orders of magnitude less than Earth's atmosphere, so for our purposes, it's effectively a vacuum. And besides being fatal to life, it's also hard on equipment. Organic materials can release volatile chemicals, which end up as a thin film on nearby equipment. Moving parts need special lubricants that don't sublimate in vacuum, and vacuum welding and heat rejection can be significant issues. Thermal extremes. The Apollo 15 site registered a 282 degrees Celsius temperature shift every lunar day. That's 507 degrees Fahrenheit. Now I like 4 seasons, but that's a little too much variation even for me. This thermal environment is damaging to exposed equipment and facilities. The equipment in partial shade could experience a significant thermal gradient, which causes stress and thermal fatigue in the material after temperature cycles. And sustained low temperatures can cause certain materials to become brittle, and electronics can be damaged by temperature cycling. And finally, the lunar surface is defined by impact events, from the large impact basins to the fine regolith dust. A 1 gram impactor will form a crater approximately 3 centimeters deep in lunar rocks. Now, the damage may be even worse if the target, such as a mining robot or a habitat, has been structurally compromised by the thermal cycling. While the chance of any particular spot getting hit by a meteoroid this size is very low, eventually something important is going to get struck. So briefly, here's how I came up with Spore. I was researching the possibility of using lunar iron to make habitat pressure hulls. I got to the point where I needed to figure out how am I going to get the iron from the rocks? And like everyone else, I started looking at how to make surface regolith mining work. And my conclusion is, it's really difficult. Albert Einstein said, "A clever person solves a problem. A wise person avoids it." So instead of figuring out how to overcome these challenges, I started working on how to avoid them or minimize them. Spore is what I landed on. I'll be using the term spore. Let me define it. Spore stands for Shielded Pressurized Oxygen Resource Extraction. Shielded from most surface threats, pressurized oxygen creates a habitable work environment. And resource extraction results in less regolith dust and a better source of raw material. Additionally, the name spore works on another level as well. In biology, spores are structures used by organisms to survive in unfavorable environments. If we can figure spore out, we can use modified versions of it to thrive anywhere throughout the solar system. Most everyone agrees that lunar habitats need to have some sort of shielding to protect them from the lunar environment. The typical solution for this is to pile regolith on top of the habitats using teleoperated robots. There are some significant problems with this strategy, however. We need high-tech, reliable, regolith-moving robots. This is obviously a significant challenge since we've been working on this for decades and we still don't have the problem completely solved. And pushing large amounts of regolith around is sure to make any dust problem worse. Of course, we don't know how bad the experience will be because we haven't done it yet. And the proposed radiation shielding thickness, I think, is insufficient for the permanent settlers. There's lots of talk about career limits for radiation exposure. I think that's fine if you're planning on short stays, but I think it's an unacceptable metric for homesteaders who are going to spend the rest of their lives there, especially if children are involved. And what would you rather have between you and a rock moving at 20 kilometers per second? 20 centimeters of loosely piled regolith, or 10 meters of compacted regolith and mega regolith? In addition, many of the challenges associated with lunar mining exist because the equipment and personnel are exposed to open space on the surface. The spore solution is to avoid the regolith as much as possible. All right, obviously I'm not an artist, but I can do okay with stick figures. So if any artists are out there, I'd really like your help ASAP. So here's what we do. We build the habitats and conduct mining activities in the mega regolith at least 10 meters below the surface. Why 10 meters? Because the median depth of the Mare regolith is about 4 meters. 10 meters will put us solidly into the mega regolith. If our homesteaders find 10 meters isn't deep enough for their site, then they go down 15 or 20. Whatever it takes to get past the regolith as quickly as possible, and it's dust. Plus 10 meters should completely protect the habitats from all external radiation sources as well as most impactors. The known issues are addressed in the appendix of this slide, the slide deck. I just wanted to let you know that I'm aware of them. So let's talk about some of the advantages of spore shielding. The lunar regolith dust is a product of millions of years of small mass impactors gardening the surface. Most of the dust is found in the first couple of meters of the regolith. And this is because impactors with enough energy to punch deeper than that are really rare. Additionally, most of the Apollo core samples showed a trend to coarser grained samples with depth. And finally, we think that the lowest layers of the regolith may transition into highly fragmented bedrock with regolith in the fractures. This would be the start of the mega regolith. 10 or more meters of shielding will eliminate radiation as a concern for habitat and mining operations, and you will have no need for radiation-hardened electronics. Additionally, monthly temperature fluctuations will no longer be a concern. Waste heat management is going to be a concern, but that's true for any lunar habitat. And throwing a meter or two of regolith over a habitat will eliminate the threat caused by the small impactors. Obviously, thicker shielding will provide better protection against larger impactors. A quick back of the envelope calculation showed that you'd need a 430 kilogram impactor, give or take, to punch through 10 meters of shielding. This would be a really rare occurrence. And if it happened, it would probably ruin your day anyway. And an extra 8 meters of shielding may not be necessary until it is. People planning on living there permanently are going to want significant protection. I'll cover this more in the resource extraction section, where impactors are a bigger threat to exposed mining equipment. And finally, we don't need complex robots. These robots are difficult to design because they need to operate reliably in a challenging environment with no maintenance for a reasonable amount of time. This is obviously a really high bar because we still don't have these things yet. Now we could wait around a long time for this technology to be developed, but then we'd be waiting a long time for settlements. With Spore, we don't need the robots. Humans have been digging tunnels and creating underground structures for a very long time. We're rather good at it. Now, there are a lot of people that are very interested in advanced robotics, especially telerobotics, so we can agree to disagree on some of this. All right, pressurized oxygen. Now that we're underground and safe for most of the surface habitats or hazards, let's eliminate the threats in our new environment. So medical extraction processes are going to produce a lot of oxygen. And here are a few of the common lunar minerals that are being considered for oxygen and metal production. And as you can see, oxygen is a major component of these minerals. So while we can use oxygen for life support and rocket propellant, we can also use the excess oxygen to make the Spore work environment habitable. The Spore solution is to pressurize the work environment with 100% oxygen at 48 kPa. So here's the reasoning behind that. 100% oxygen because some unknown and probably highly variable amount of gas is going to leak away through the exposed Regolith mine face. We don't know how much because we don't have Regolith samples. We really don't know much about the Regolith. But we don't want to lose that expensive nitrogen in our habitat breathing gas. So we'll go with the cheaper pure oxygen that we produce locally. 48 kPa because I've defined a 78% nitrogen, 21% oxygen mix at 70 kPa as one standard lunar Homestead atmosphere. Now you can cut atmospheric pressure in half without risking decompression injury or needing to pre-breathe oxygen. So half of 70 kPa is 35 kPa, which is about what was used for all the Mercury, Gemini, and Apollo missions. So we know people can deal with this for several weeks at a time. 48 kPa gives us a solid safety margin if the pressure starts to fall faster than expected. Homesteaders can immediately retreat to the safety of the habitat. However, people in the Spore working area won't directly breathe the atmosphere. They'll wear some sort of full-face breathing gear connected to an air supply by an umbilical. But if there is a problem, homesteaders could survive in the work area long enough to get back to the habitat. A pressurized work area with a breathable atmosphere comes with several advantages. Spore creates a habitable, if not comfortable, environment in the work area. The vacuum threat is minimized, so spacesuits are not necessary. And at this pressure, homesteaders can move freely between the Spore work area and the habitat. Lunch and bio breaks won't require eating from a tube or using adult diapers. And I'm looking at used spacesuits. Homesteaders can also quickly retreat to the habitat if something goes wrong. And it's not just the regolith dust we need to worry about. Any mining operation is going to generate copious amounts of regular dust as well. And we can still look into electrostatic and magnetic techniques for dealing with dust. They may work even better in a contained area. But with an actual atmosphere, we can explore other options, such as using air circulation and lunar-made filters. I mean, heck, we can even use a water spray to remove dust from the air. It may get a little messy, but with clever planning, we should be able to recover almost all of the water. And equipment doesn't have to be designed for the surface environment. They can be simplified. We can explore other options, such as hand or pneumatic tools. It gives us a lot more variability. And the atmosphere will also help us manage the thermal environment. We can use circulation, portable water chillers to keep the work area comfortable. We have more options. Resource extraction. This is what we're all working towards, right? So the standard solution is basically open pit mining of the regolith using robots. And there's two big problems with this strategy as I see it. One, it takes place on the surface, and two, it actively engages with the regolith. And as we've learned, the surface is a tough place for equipment, and the regolith only adds to the challenge. And it's also a dangerous place for people, which is of course why we're using robots in the first place. And as I mentioned before, we've been working on this problem for a long time, and we still don't have robots that will meet these requirements. Another problem with surface mining that I haven't addressed yet is the low gravity. On Earth, we rely on gravity to provide enough traction for Earth-moving equipment to operate. It's Newton's third law. Basically, every action, there is an equal and opposite reaction. A bulldozer pushes against the ground pushes back with equal and opposite force, but the bulldozer is really heavy, and so the pushback has much less effect. On Luna, there's 1/6 the gravity, and therefore 1/6 the countering force. So we'll either have to greatly increase the mass of our machines, secure them to the surface somehow, or be okay with them doing a lot less work. And of course, all these solutions come with their own problems. The Spore solution is to avoid all of this mess. Avoid the regolith, go straight for the mega regolith, and use people to do it, not complicated robots. I've already explained why going directly underground eliminates or minimizes most of the challenges associated with surface operations. But by building the system around human miners instead of high-tech robots, we take a lot of the uncertainty, complexity, and expense out of the equation. Sure, we have to provide for life support and food and all the other stuff that humans need, but we're doing that anyway because we're building a settlement and not a robot farm. And now we don't have to wait for the robot tech to advance to the point where we can actually use it. And homesteaders aren't relying on expensive tech that ties them to Earth. Spore can use human miners because the work environment will be a protected, habitable space. And finally, the final component for Spore resource extraction are low-tech tools. These may not be the most efficient tools for the job or the most sexy tools for the job, but they have several advantages, including lower power requirements, easier maintenance, and local manufacture. It's probably a lot easier to make a pickaxe out of lunar iron than a teleoperated mining robot. So let's look at some of the benefits of Spore resource extraction. Safety again. Homestead miners are protected from regolith dust, radiation, vacuum, thermal extremes, meteoroid impacts. They're also safer in general because they're working in a habitable environment and the habitat is literally meters away if anything goes wrong. Operating in an enclosed space might help with the low gravity. We may be able to temporarily secure the miners and mining equipment to the Spore structure, allowing people and equipment to work more efficiently. Regolith formation and evolution is a complex process driven by the completely random destruction and creation of material by impactors. Throw in excavation and ballistic sedimentation of existing layers with the effects of solar and cosmic particles, and the end result is, and I quote from the Lunar source book, a regolith whose structure, stratigraphy, and history may vary widely, even between locations only a few meters apart. Instead of trying to design equipment to deal with this mess, Spore avoids it by targeting the large blocks of basalt that we think are the primary components of the Mare mega regolith. Okay, don't get me wrong, I'm not knocking the companies that make simulants. Simulating the lunar regolith is a tough challenge, and simulants are absolutely necessary for many applications. However, the lunar and Earth basalt are physically and chemically similar. Bypassing the regolith and focusing on the basalt bedrock ejecta of the mega regolith will avoid a lot of complexity and uncertainty. So how does creating habitable space while we're extracting resources sound? We can do that with Spore. Spore is a modified version of a tunneling shield. Now, tunneling shields were first used in 1825 to excavate the Thames Tunnel. They're used primarily for ground that is soft or unstable and protect workers from falling materials and cave-ins. The key feature here, though, is that as the excavation moves forward, a permanent structure is built to line and support the tunnel left behind. Another one of my great artistic attempts. With Spore, that structure will be the habitat pressure hull. When enough hull has been built, we'll seal it off, and then presto, we have a potentially habitable space. Of course, we'll have to install all the equipment necessary to actually make the space livable, but that's a whole another problem. My original idea was to use the iron we extract from basalt to make the pressure hull. That idea is still in the works. But I've also started looking at using the basalt itself as a pressure hull material, perhaps with cast basalt components. And for the future, who knows? Humans can build amazing things given enough time and motivation, maybe even large underground lunar cities. Let's look at some of the advantages that Spore habitat creation offers. The habitats are immediately protected as they are built. We don't have to wait for robots to build up enough regolith on top of them before we allow people in. We don't have to worry about inadequate shielding. Immediately protected. Extracting the resources necessary to create the settlement and creating the settlement are the same activity. This should reduce the amount of equipment we need to ship from Earth. And we can even bypass the whole resource processing step by shipping habitat hull components from Earth and speed up the whole settlement construction process. Tunneling shields, underground mining, basalt processing are all pretty mature technologies. We just need to adapt them to their new environment. We don't need to design or develop teleoperated robotic regolith movers or lunar surface-rated 3D printers or inflatables or all the other untried and underdeveloped technologies. There are a few other advantages I haven't mentioned that come along with Spore. The simple version of this problem is that rocket exhaust gases send loose regolith flying at high velocity. Now, that's not just dust. Some of the rocks can be pretty large depending on how powerful the rocket is. And obviously, fast-moving rocks are a threat to anything on the surface, structures, people, and equipment. So one of the rules for lunar homesteading is to place as much of the settlement underground as possible. Spore can allow homesteaders to create a lot of underground space. Underground structures will not be affected by plume-propelled rocks. I'm also toying with the idea of using Spore to build subsurface landing pads. Rockets could land and then be moved into a habitable space for unloading and maintenance, again, avoiding the regolith altogether. The Apollo seismic network registered 28 shallow quakes between 1972 and 1977. Several of these were up to 5.5 on the Richter scale, and some lasted more than 10 minutes. These are considered moderate and powerful enough to damage poorly constructed buildings on Earth. And on Earth, even the biggest quakes stop after less than 2 minutes. So more than 10 minutes of shaking, even if it's not very powerful, can put a lot of stress on structures. It can cause fatigue that weakens the building materials and can create air leaks at seams and seals. It's also going to be a pretty unpleasant experience. And we really have no idea how moonquakes will affect surface mining operations. Pits and trenches in use could collapse. They could bury equipment and personnel. Equipment could be knocked over. Now, I'm not a civil engineer, but from the few articles I've read, it seems that surface structures are more affected because of the layers of soil they sit on. Structures tied into the bedrock, like skyscrapers, are better protected. Structures inside the bedrock are even more protected. It's unclear how homestead habitats embedded in the mega regolith will fare, but it's a safe guess that they'll probably be better protected than any surface structure as they will move with the materials surrounding them. From excavation equipment to habitat pressure hulls, the more equipment homesteaders can build and maintain themselves, the better. The lower overall technology needed for Spore should allow settlements to substantially reduce their need for equipment from Earth. Of course, we won't really know how low tech we can go until we try. All right, this may not seem like a big problem now, but large-scale open pit mining of the regolith could experience some significant public opposition. We start messing with how their moon looks, and we're going to see a reaction. Almost everything associated with lunar homesteading is underground, and surface disruption could be minimal. And finally, lunar settlement for everyone. Now, this is the Lunar Homestead slogan, but what it really means is that anyone can help move lunar settlement technology and techniques forward. You don't need to have a lot of money or work in a lab or have an advanced degree. Helping us consolidate our knowledge base is a useful form of research, and we desperately need that. And conducting small-scale research projects in your home is feasible and can produce useful information. And lunar settlement isn't just for elite astronauts or select corporate employees. We're not going to create lunar, Martian, or solar civilizations by sending the chosen few on limited missions. Lunar Homestead is working to create the tech needed to enable anyone to carve out their destiny on the lunar frontier. All right, so what am I working on next for Spore? I've been working on the Spore pressure experiment 1 for a while, and I'm going to try to get some data on the atmospheric leakage through the mega regolith. Now, obviously, we don't know much about mega regolith, and I don't have a lab. It's more of a proof of concept than an actual simulation because there are a lot of variables and unknowns. And I'm also starting to work on computer and physical modeling to help everyone visualize how Spore would work. And book 3 of the Lunar Homesteader Survival Guides, which I'm writing, will have a chapter dedicated to Spore. I'm more than halfway through book 1, so book 3 will probably be sometime next year. And of course, I'd like to tell more people about Spore and Lunar Homestead. So speaking of Lunar Homestead, my website has much more information on Spore and other topics. And I've also included a lot of information in the appendix section of this presentation, which you probably won't see now, but you can see later when we post it. And finally, you can email me any questions or comments you might have. All right, thank you for your time. So what questions do you have?
Yeah, thanks a lot, Ben. That was really great. Let's see. Does anyone have any questions? I don't see any in the Q&A. Let's take a look at the chat.
All right, I'm going to stop sharing.
Okay. If anyone has a question, just go ahead and raise your hand. Dana Carson made a comment that there are companies that make cast basalt counters and pipes for chemical processing.
Yep, cast basalt is a mature technology. Just need to figure out how to adapt it to lunar environment.
Mm-hmm. And then Bill Clausen asked or I guess this is kind of half comment, half question. The enormous pit mining machine isn't problematic enough? Question mark.
Yeah, I like that graphic. I saw that and I was like, yeah, I have to use that. Yeah, I think any large-scale pit mining is going to be problematic in a lot of ways.
Mm-hmm.
I mean, from just the sheer technology we have to design and build to get us to that point, to changing the visual effects or visual looks of the lunar environment, to messing up the environment itself.
Ben Stanley, do you have a question? Your hand's raised. You can go ahead and unmute yourself.
Yeah, I was just wondering if you've thought about doing as kind of like a proof of concept thing, trying to actually find some lava fields on Earth that you could try to dig down into and try to create and test a pressure chamber. That'd be kind of a cool project.
That would. That'd also be a expensive project. And I am not Elon Musk, so that would be great. I think there are a lot of other interim steps that we could do, definitely. And since a lot of it is based on the tunneling shield, we could just build a Spore-like environment just using a surface pressurized area, and that would probably test out a lot of it. But that's much farther into the future.
Dana Carson, do you have a question?
For you.
As a extra source of raw material, the inside of lava tubes is protected, and there's usually lots of loose debris that has fallen from the roof. So you could gather up reasonable sized chunks of rock there to add to your raw material sources.
Yeah, I have concerns about the lava tube for a couple of reasons. They may have been relatively stable over long periods of time, but that was before you put human activity into them. And so if you start introducing heat and waste gas and humidity, just anything that changes the interior of those tubes, I think that could cause a significant problem with tube stability, just because we will massively change the environment. I think that's just something that we would have to go and learn. We'd have to go find a lava tube. I mean, right now we do not have any physical confirmation that they exist. We have skylights and we have some observational data, but obviously we've never put a robot in it. So until we actually go to the lava tubes and see what they're really like and find out what the environment is and maybe seal one off and pump a bunch of oxygen into it, just see what happens. But until then, I think relying on them is more in the future.
Well, I was talking more for extra raw material, not for setting up your habitation in them. Just dragging boulders out of them.
Oh, so just going in and trying to get some basalt boulders out of them?
Mm-hmm.
I mean, that could work. I mean, I guess it would depend on how easy we could get in there and grab the material and take it to wherever it needs to go. So let's see, I see some questions in chat here.
So yeah, there's some in the Q&A there. So Grace Rober is asking, dig a hole somewhere in any US desert, question mark? Create an analog moon base to see proof of concept.
Maybe eventually. Yeah, there's a lot we don't know about the mega regolith. We never got a sample down that far. The deepest core samples that Apollo took was about 3 meters. Mega regolith starts below that. So all of our data is basically based off a little bit of seismic information and some modeling. So we think that it's large blocks of basalt with regolith in between, but we really don't know. So I mean, digging in a desert or in a beach would be one way to go. It could end up being much more like hard rock mining, in which case the idea of going to a volcanic field would probably be a better analog. But there's a lot of research to do before from here to there.
James Melton, did you want to maybe ask your question? You want to unmute yourself and ask?
Yeah, hi. Enjoyed your program very much. Very thought-provoking. I'm just wondering what Elon Musk's boring process might play in this equation. I know the individual work that the people would do themselves with the picks and hammers and that sort of thing would be fine, but maybe an initial good start on it might be the boring equipment.
Yeah, I have no information about that. But yeah, I mean, here's my reasoning behind the low tech. There's a couple of reasons. One, I'm just curious to see how low tech we can get away with, because the default is usually what new toys can we create, and that creates some other issues. So I'm just curious to see, can we get away with low tech, or where that level is. And then the second thing with the low tech I'm interested in is low tech could probably be manufactured and maintained faster on site than high tech. So if we could get away with a shovel, we could probably build that a lot sooner than we could a robot. And the third reason I like low tech is civilization needs a low tech base to fall back on in case something breaks. All the high tech toys are great, but if they break and you can't get a part, or if it breaks so bad you can't fix it, it would be nice to know that we could always fall back on a lower level technology until we get back to the higher level.
All good points, Bill. Thank you.
It's good to hear your voice, James.
And yours.
All right, thank you. Arvin Tan has a question. Do you have an initial crew member estimate for implementing the underground deployment of one Spore habitat? How many will be needed to excavate?
Yeah, I haven't really gotten into that kind of nuts and bolts yet on that. In my head, I'm thinking probably initially it would be like a 2-man crew, something very very simple, you know, reduce the life support requirements. Not saying it'd be easy. It'd probably be a pretty crappy job for a while until you've dug out enough habitable space and gotten enough resources. But I'm thinking keep it simple. And if you look at my site and I talk about lunar homesteading in general, my philosophy is that people are going to go, and they're going to go to stay. They're not. This isn't a short duration mission. You know, they're homesteaders. The first couple people are pathfinders. They go out there and they break the ground. They break trail, and they get in there and they create some habitable space and they get some resources going, and more resources are landed, and then more people can come as soon as you got more space and resources to support them, which then of course increases the trajectory or the rate of expansion for the homestead. So yeah, start small and simple, and you know, if that's not viable, then we always go for something a little bigger. But I think we should definitely go for least cost, most simplicity.
Jaden Sage asks, do you foresee most settlements occurring below ground?
I think they have to. I mean, the lunar surface environment is harsh. It's difficult to design equipment for. And one of the things that kind of bugs me about a lot of the pictures and graphics created about lunar settlements, you always see people walking around outside in spacesuits. Lots of them, like it's not a big deal. But going out on the lunar surface is going to be a big deal in reality. I mean, it's not even going to be a big deal like, oh, I'm going to go scuba diving. It's going to be more like, I'm going to have to get into some commercial gear and have a whole bunch of support with me to go out and do this thing. And so I think that the reality of lunar settlement is that everybody's going to want to be underground because that's where the safety is. And you know, the surface activity is going to be limited to robots and some highly trained people who are willing to take that risk.
Next question from Ben Stanley. Do we have any info on mega regolith based on what's been exposed in the strata of younger impact craters on the moon?
We have a little bit. Doesn't really tell us much though, because once a crater's dug into it, you can't get anything about density or stuff. We can kind of, and it's all remote imaging at this point. So we know a little bit about it, but most of it is just modeling and conjecture. We know it's there, and that's pretty much it. We think that the mega regolith is composed of bedrock ejecta from much larger impacts a long time ago. And then, of course, because of the way the lunar surface is evolved, you get a lot more of the small stuff hitting, which breaks up the near surface area a lot more. So unless something big comes along, eventually you get a layer of really fine dust, and then you get coarser stuff as you go down because it hasn't been penetrated as often, because those big penetrators are really rare. And so we think that, you know, you get beyond the regolith where it's mostly this coarse stuff, well, fine to coarse, and then you start getting into just larger blocks, maybe a meter in diameter or more. And then the further you go down, you get larger and larger blocks and less regolith until eventually you get to undisturbed bedrock, which I think they think is about 1.5 to 2 kilometers down.
Bruce McKenzie, do you have a question?
Yes, it refers to laser cutters, whether you might be able to cut the rock with lasers. I was working on something that was interestingly called a Mars Homestead, just like your lunar homestead. And we needed big chunks of masonry, you know, rock for building with masonry. And we looked into using laser cutters to cut out tunnels, but we never found enough information about it to actually do, you know, cost and energy estimates. But I suggest you look into it. The lasers might be much lower mass to bring from Earth, and perhaps during the lunar daytime, you might have surplus power to run them. And also, you might be able to defocus the lasers and use them to kind of sinter or melt the ceiling so it doesn't leak. That's all.
Yep. Yeah, and I mean, that's definitely a technology that could be looked into, probably by somebody who knows a lot more about it than me. the fourth reason why I like low tech is I understand it better, and I could actually do the research with it a lot better. But I mean, yeah, I mean, there's nothing to stop somebody from researching using laser cutters, or I've seen ideas where you use some kind of thermal plug to melt the rock and just push it through. Yeah, there's all kinds of things. I mean, the thing with the mega regolith is that if it's solid blocks of rock with regolith in between, then we don't really need to worry about the spore atmosphere bleeding out through the solid blocks of rock. It's, you know, it's the gaps in between the rocks is where you're going to get the leakage from. And from things that I've read, and from experiences with the Apollo astronauts, the regolith is really tightly packed. It's very high density. In fact, they had a really hard time getting the equipment into the regolith to take samples. So there's every reason to believe that the regolith that's in between these boulders is pretty densely packed as well. And if you've got 10 plus meters of rock and regolith between you and the vacuum, the bleed out of the atmosphere from the spore work area may not be too bad. And you got to remember, as it's moving forward, you're lining the tunnel behind you. So the only area you're bleeding out of is at the rock face or the mine face, which isn't that big of an area. So, and this is something we really won't know until we do it. I mean, we'd have to get a lot more data on the mega regolith to simulate it here. I mean, at the end of the day, it's going to be something where we're just going to roll the dice on that.
What you just said kind of leads into this question. When there is actual regolith samples, how much do you see your assumptions adjusting, or would the core principles still apply?
Well, regolith samples does not change. We know the regolith is a beast. The dust is just bad. I mean, a lot of people really underestimate how much of a deal breaker dust can be. And so more regolith samples doesn't change the core assumption for spore. Spore is get under the regolith and leave it alone. Because the stuff packing in between the basalt ejecta is most likely not the really fine stuff. All that stuff is produced on the surface with the small impactors. So stuff that's packing in between the boulders is probably fairly coarse. So we really shouldn't have to worry about that fine regolith dust. As soon as we start getting some mega regolith samples, well, yeah, then things might really change. But the other thing is that one sample or one sample site doesn't make the moon. As we've seen, you could take samples from the same site and have things that are completely different. So I think it's a better way to design the technology to be adaptable and clever, anticipate that we don't know anything, and have the technology be able to react. So like one of the things I think about is, let's say they're mining along and they hit a void, and all of a sudden the pressure starts to drop because that void is just, probably not exposed to the surface, because that would require a long fissure or something, but it's still a void. So what would they do? Well, we need to have some techniques in place. Two of the things that I think about is, well, maybe they have a couple of buckets of processed material, fine processed material, and they just throw it into the void and it packs that void in temporarily. Or maybe you could throw water in there and it'll freeze temporarily as a patch. So we just need to think of clever ways to do this and not rely so much on knowing what we're going to encounter, because we really won't.
Okay, this may be the last question from Michael Boezo. You mentioned we could do experiments at home. Is there any way we can help with Spore or completing research? Do you need any volunteers or help in any way?
I need lots of volunteers and help. Go to the website. There's all kinds of information there. Spore is what I'm working on. I'll take as much help as I can get. Ideas, not really at the research stage, although, like I said, I am working on this Spore pressure experiment 1. I've had a bit of trouble with it because I bought some basalt gravel, and my thought was, I'll just break this gravel up into particle sizes that I can then use. Well, breaking gravel, basalt gravel, is hard. I've gone through 4 different manual experiments with it, and all of them have failed pretty badly. So I don't have the facilities to get like a big gravel breaking machine at the moment, maybe next year sometime, but I'm still looking about how I'm going to do that experiment. So I could definitely use some ideas and help and stuff like that. There is so much we don't know that we need to know for a lunar settlement. Anybody who says, oh, we can throw a settlement down at any time is not thinking about it. I mean, we don't know. We don't have the technology. We don't have the techniques for long-term settlement, especially if you think about how would you adapt that to making it on the moon? You know, it's one thing to be able to ship a bunch of stuff in from Earth, but then how would you modify that stuff so you can make it using basic lunar materials? I mean, that's another big question that Lunar Homestead is trying to solve. You know, it's one thing to make a lab test for ilmenite ISRU, you know, breaking that down into iron and oxygen. It's an absolutely different thing to ask, how would homesteaders do that using their resources available to them and not having to ship everything from Earth? So the amount of stuff we need to figure out is astonishing. And anything that you're interested in can be turned into a research project. You don't even have to do physical experiments. There's a lot of information out there, but it's scattered. There's so much stuff, you know, hidden in old conference books or buried in papers or behind a paywall somewhere. And one of the things I'd like to do is just start gathering all of that information. Lunarpedia that we've mentioned is going to be a great source for that. If we could put everything we know about lunar basalt in there, and then everything we know about Earth basalt in there, we would be steps ahead of the process of then figuring out how can we process lunar basalt. So yeah, I mean, there is, if you can imagine it, we can figure out how to make it a useful research project.
Awesome. And then one final comment from Ben Stanley. I think we might be surprised at just how diverse we discover the moon to be.
Oh yeah, I figure we know just enough to be dangerous. There is so much about the moon that we don't know about, that we don't even know the questions to ask to figure out. It's a lot like, you know, the deep oceans. They say we've only explored 5% of the oceans. Well, I mean, we probably explore, you know less than 5% of what we need to know about the moon. So yeah, all kinds of things we need to figure out before we can start settling there. And the good thing is that once we're there, that's when we're really going to learn.
That's when the knowledge will really accelerate and the
Oh,
applied
yeah.
physics comes in. Yeah.
Yeah, because I mean, it's another world. You can't explore another world in just, you know, a couple of decades with a few robots and maybe a couple of humans. It's going to take us a long time to become very familiar with it.
Absolutely. All right, Ben, thank you very much. That was great.
Great, thanks.
Good job.